Hey guys, Mr. Piercy here, and what I wanted to do is make a quick video to show you how the properties of a midsegment of a triangle actually, came to be. It's not just something that I want you to say, well, I'm the teacher, trust my judgment, and why would I lie to you? Okay, again, the nice thing about geometry is that pretty much you can always show or see where it came from in the first place. So here I have a triangle ABC, and what I'm going to do is we're going to create the mid segments of this triangle. So I'm going to begin by constructing where the midpoints are. So using my compass and my straight edge, I'm going to say, well, here's a midpoint here, and I'm going to just do that for the three sides. And here's another midpoint. And one more side to go. And 1, 2. You can see how quickly doing multiple constructions on the same figure can look a little disorganized. Okay, so I'm going to call X, Y, Z. I'm going to call those my midpoints. And what I'm going to do is with my straight edge, I'm going to connect the midpoints together to actually make my mid segments. Now, I'm going to go ahead and just clean up these construction marks here. You can still kind of see them. I just want them to not be completely in the way. Now, the other thing that I'm going to need for this particular construction or investigation is a piece of patty paper or something semi-transparent, so that way I can copy. Oh, my protractor moved. So that way I can copy my triangle and manipulate it fairly simply. Now, one of the characteristics of the mid segment is that it is parallel to the third side of the triangle. So if I did my constructions properly, segment XZ should be parallel to segment CA. Now, how do I test for that? Well, looking here, we see, obviously because I just copied it, that the triangle on my patty paper and the triangle on the notebook paper are congruent. So what I'm going to do is I'm going to slide the patty paper. So I'm going to take this point here and I'm going to slide it to this point here. And what we're going to recognize is, by visual confirmation, the corresponding angles at point X and point C are congruent to each other. And as we've used on multiple occasions in previous lessons, if corresponding angles are congruent to each other, then the converse says that the lines must be parallel to each other. So looking here, again, we can look at it from the other side. Here where point A is and here where point Z is, if I move those and compare them to each other, we again see that the corresponding side, or the corresponding angles rather, are parallel to each, or are congruent to each other rather. And because the corresponding angles are congruent, it means that the segments, in this case ZX and AC, must be parallel to each other. Well, does that work for all of the mid-segments? And you can check that very easily. Well, now let's look at XY. So we can take this point B and put it here at X, and again see that the corresponding angles are the same. So indeed, this is a very simple way of seeing, because we have corresponding angles that are congruent to each other, the lines, the segments must be parallel. Well, the other thing about midsegments is that we say that the midsegment must be half as long as the third side of the triangle. So let's compare that. So here I'm looking at the midsegment ZX. If I take that and I bring it down here to the third side of the triangle, I can see that this midsegment, so here's one length, and we can spin it around and see, well, here's a second length. So yes, we can see very easily, at least on this particular one, that the midsegment is going to be half as long as the third side of the triangle. Was that true for all of them? Well, let's take a look at XY again. Well, XY is parallel to AB. So if I take that here, I can see it's going to take one segment and two segments again. And it will work for the third one also. So we can take the last one we would have to look at would be ZY being parallel to BC. So 1 and 2. So here again, this was just a quick demonstration that I wanted to show you as far as why we say that the midsegment of a triangle is parallel to the third side of the third side, and why it's going to be half as long. The only other thing that we might want to point out to you here is that every triangle inside of the figure, so when we construct the midsegments, it divides it up into 4 smaller triangles. Well, looking at the patty paper, we can very easily determine very quickly that all of the triangles inside are congruent to each other. So anyway, that's pretty much all we need to talk about right now for midsegments of triangles. Midsegments will be something that comes back later on when we talk about trapezoids. But for now, that's the important information that we need to know about midsegments of triangles. So I hope you learned something, and if you have any questions for me, make sure you send them to me in an email, and I'll be happy to answer any questions that you may have.